Okay, let's look at problem 311 in chapter number 3, because he gave you here the dimensionless Henry law constant for trichloroethylene TCE at 25 Celsius is 0.4. So the Henry constant is 0.4. A sealed glass vial is prepared that has an air volume of 4 milliliters. So there's a vial. So we'll just try to draw it here. And this vial has 4 mL of air. So the air volume of air is 4 milliliter. Overlaying an aqueous volume of 36 milliliters. So this is volume of water or aqueous, 36 milliliter. TCE is added to the aqueous phase so that initially it has an aqueous phase concentration of 100 part per billion. 100 part per billion. After the system is equilibrate, what will be the concentration in units of microgram per liter of TCE in the aqueous phase? Okay, so let's look at, first of all, we'll do the same mass balance we did in the example in the note. So the mass total entering is equal mass of TCE in water or aqueous plus mass of TCE in air. So I'll leave it like this. Now, what is the mass total? Remember, he is giving you that it's equal to, let's see, it is 36. So let's find out the mass aqueous. The mass aqueous is, you multiply, remember from the notes, multiply concentration, aqueous, okay, times volume. What is the volume for water? 36 milliliter. And remember the concentration is milligram per liter, so we have to convert this into liter. Remember, the C is in milligram per liter. This is obviously what we do all the time. So we have to convert the milliliter here into a liter. Okay? So that's for the water or for the aqueous solution. Plus air, it's the same thing. C, air, the concentration of TC in air, times, remember, 4 milliliter. And of course, do the same thing. Nice. So now we should find out the total concentration of trichloroethylene that was added to the aqueous phase. So TCE was added to the aqueous phase. Okay? So we're going to put the solution 100 part per billion. Remember from the air, if it is milligram per liter is part per million, part per billion is microgram per liter. So it's 100 microgram per liter because it's part per billion. And now times what? We put it in the water, in the aqueous solution, 36 ml. And we could convert this ml to liter in order to cancel out ml with ml, liter with liter. So it's 100 microgram. Okay, so we are done from this. Now we have to convert this to C aqueous. Okay, remember the KH is 0.4, and this is dimensionless. You don't have to transfer this. You do not have to divide this by R and temperature because it's already dimensionless. So this is what is equal to what? C air over C aqueous. Okay, so this should be done like this, that the sea air is equal 0.4 sea aqueous. So now we'll do it like this. This is 100 divided by this, so 3.6 microgram is equal sea aqueous, 36 over 1,000 plus sea air. We'll do it like this, 0.4 sea aqueous. Okay, 0.4 times sea aqueous times 4 over 1,000. Now we take sea aqueous as a common factor, and we could determine, it's going to be like this, 3.6 is equal sea aqueous, 36 over 1,000, it's 0.036 plus 0.4, so this is 4 over 10, and then 4, 1,000. 4 times 4 is 16. 16 over 10, it's here, 1, 2, 1, 2, 3. So it will be like this, 1, 2, 3, 16, so 4. So 1, 2, 3, 4. That's good. So it's 0.00. So now we could find sea aqueous by dividing this over this. So sea aqueous is equal to 96. And since this is in microgram and everything else in liter, so it's 96 microgram per liter. We change everything to liters. So this is the concentration that is after equilibrium. That's the concentration of TC in the aqueous phase. Okay? The rest, remember, it was 100 part per billion. So initially was 90, initially was 100. So 96 gonna be here, and 4 microgram per liter gonna go to the air. Okay? Not the whole 100 part per billion will stay in solution, but will go to air. Okay? Thank you very much.